Snell's Law in your calculations. Allison sees a coin at the bottom of her swimming pool at an angle of 40 degrees to the normal, and she dives in to retrieve it. However, Allison is on water, so she must rely on her initial observations of the coin made in the air. At what angle does the light from the coin travel as it moves towards the surface? And you've been given that the index of refraction in water is 1.33. All right, it helps if you draw a little sketch of what's going on here. So here I have the air. Here's my water. Always, always, always draw in your normal. And here's Allison's eye. And looking at a coin down at the bottom of the pool. Okay, so what you would do is you would kind of sketch. We've got the light bouncing off of the coin, hitting that boundary, and then changing directions due to a change in the speed of light. This down here, with respect to the normal, would be one angle. This would be the second angle. Now we're given that the index of refraction in water is 1.33. And I'm going to put just a little W to indicate that it's water. 1.33. And we know from the constants on our formula sheet that the index of refraction in air is 1.00. So I'm going to use Snell's Law and plug in the numbers where they belong. So Snell's Law states that the index of refraction on the incident side multiplied by the sine of the angle on that incident side is equal to the index of refraction on the refracted side multiplied by the sine of the angle on that refracted side. Okay, now I'm just going to go ahead and choose. It doesn't matter which one you choose, but just choose a side to equal the air and choose a side to be the water. So I'm just going to choose this side. All of this will represent my side on water, and all of this will represent the side on air. So let's plug in our formula with the numbers that we were given. 1.33, which is the index of refraction of water, multiplied by the sine of my angle, and I don't know what this angle is equal to the index of refraction in air, which is 1, multiplied by the sine of my angle in air, and that was given to us in the formula. Now, when she sees it, remember, Allison is standing in the air. Therefore, this angle must be the angle that is up here on the air side. All right, so the next thing I'm going to do is I'm going to simplify this a bit. I'm going to take 1.33 sine of theta is equal to, now make sure that your calculator is set in degree mode. And the way that you do that is you click on mode and your screen will show up. Let's zoom out a bit here. See if this will help. At least with the calculator it will. Okay, once you press on mode, what you want to look at is to make sure that degree is highlighted. If it is, then you are free to go. If it's not, then change it from radians to degrees. So go ahead and type in the sine of 40 and get a number, an actual number. This is 0.6427. Now this times 1 is going to be itself, so I'm just going to write 64278 6097. All right, now the next thing I need to do is get sine of theta to be by itself, and since it's being multiplied by 1.33, to get rid of it, I would divide 1.3, and whatever you do to one side of the equal sign, you must do to the other. So let me just go ahead and type that into the calculator, and I get the sine of theta is equal to 0.48329 ... This is the sine of theta. We didn't ask, or they're not asking for the sine of theta, they're asking for theta itself. So, to get rid of the word sine, you do what's called the inverse sine. And that will cancel out. Whatever you do to one side of the equal sign, though, you've got to do to the other. So theta is going to equal to the inverse sine of 0.48329. 3298 dot 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 dot. And at this point, you want to let your calculator do the actual calculation for you. Okay, this is how you do it. You hit second, and then you're going to press the sign. You see that little sign to the -1? That is the inverse function. There it is, sine -1. And now we want the previous answer that was given to us in the calculator to be put into that parentheses. You can do that by pressing second, then all the way at the bottom, you'll hit ants, ANS, which is also the negative sign, and that's what you'll see on the calculator. Inverse sign of the last answer, then hit enter, and you get 28.9, and this will be in degrees. And that's it.